Good morning, everyone. Let me check this. Okay. Good morning, everyone. So today's lesson is going to be 1.1 polynomial operations. So just adding, subtracting, and some multiplying. But before we do that, we would need to go over some vocabulary, okay? So first of all, a general polynomial. Well, a polynomial, your n, which is your exponent, has to be a whole number. So let's remember a whole number is no decimals, fractions, or negatives. So 1, 2, 3, 4, 5, 6, 7. Okay. Now, and 0 because 0 is a whole number. Degree. The degree of the polynomial is the largest exponent. So it's not always the first term you see, because sometimes it's not in the correct order it needs to be. The correct order of a polynomial means the highest degree to the smallest degree. And the actual exponent, the largest exponent is the smallest exponent. The degree of the polynomial is the largest exponent. Okay. Now, when you rearrange the polynomial to get your general form where the largest exponent is in front and all the way down, that allows you to find the leading coefficient. The leading coefficient is the coefficient or the number, right, in front of the largest exponent. Now, our constant is our term without a variable. So it's just a number. So our constant is the term without variable. Hopefully you guys are not picking up the screaming I'm hearing during the halls when those sports teams is running around. Okay, standard form. What is standard form? Standard form is meaning that the terms of the polynomial are in order from largest exponent to the smallest. Or really, if you have a constant, that constant's the last one. The reason why there's no variable is because the variable is to the 0 power. We'll talk more about that later. Okay, so when we classify polynomials, you'll see that there are sometimes names that we have for these. Okay, so 0, meaning it's just 0, right? There's no degree there. The exponent is 0. See, no exponent, so the exponent is 0. A constant means that the degree is 0. Oh, here we go. Sorry, it says 0. It's supposed to be none. So 0 means there's no number, right? No variable, so there must be no degree. A constant is when you have 1, 2, 3, things like that. There's no variable because the exponent is 0, giving that degree of 0. Linear, okay, that means your exponent, your highest exponent is 1, so that's the degree of 1. Quadratic, your highest exponent is 2. the degree of 2. And some of this should look familiar for what we did for the last couple of years. A cubic is where your highest exponent is 3, so it's degree 3. Okay, and then sometimes there's other names, but otherwise we just go 4th degree, 5th degree, so on and so on. All right, so what are we going to review about polynomials right here? What we're going to do first is we're going to add and subtract these polynomials. So in other words, combine like terms. There's a couple of ways that we can do this. First of all, problems are going to be set up like this. This is how questions will be given to us. But really, there are 2 ways that we can solve this. We can do a horizontal method, okay, and just combine like terms, or we can do a vertical method where we can put the terms in the same place according to their exponent. I like doing it horizontal because I've always combined it like terms by putting a special shape around that term. So like here, I may put a square around my cubes. So I know I have to add these 2 together. I might put a line under my squares. So I know I have to add these 2 together. I'm going to circle my to the first. Now I can't forget to have that negative there, that subtraction, because of course I'm having a 4 plus a negative 5. And then I have my constant. Let's do a diamond. Now, will you always have terms that add and subtract to another? No. If we didn't have this constant here, we would just say, hey, that -1 doesn't add with anything, and we just add that in at the end. So let's add these now. I'm going to add the shapes and also do it in order for the standard form. So highest exponent to the lowest. So my highest exponent are cubes. So I have 2x cubed here. And what does it mean when there's no number in front? 1. So I have 2 here and 1 here. We're adding them together. So I have 3x cubed. The other thing to keep in mind is when we're combining like terms, the terms that look like each other, you do not add the exponents together, right? It's like, hey, I'm going to add 5 apples here and 2 apples here. How many apples do I have? I have 7. You don't change the apple. There's still 7 apples. Let's look at our x squareds. We have -3 here and 2 here. So -3 plus 2 is -1. And you do not have to put the negative, or you don't have to put the 1. You have to put the minus, of course. But you do not have to put the 1 if you don't want to. Next, I'm going to go to my x to the first. I have 4 here and -5 here. I'm going to add them together, and I have again -1x. And then my constants, -1 plus 3 is +2. And we are all done. Now, if you want to show you really quickly the vertical, if I did the vertical here, I would take that first polynomial, which is 2x cubed minus 3x squared plus 4x minus 1. And then I'm going to add. In the second polynomial, I'm going to make sure I line the terms up with ones that look like each other. So my x cubed goes here, and x cubed, I almost put squared. And I'm going to put a 1 in front just to remind myself to add down. Then I have this plus 2x squared minus 5x plus 3. And then as you can see, I can just go straight down. 3x cubed minus 1x squared minus 1x plus 2. So you get to choose on which way you would like to do these. All right, let's go on to the next page. Now we have a subtraction. Watch out though. So what I always like to define is this is subtraction ahead of time, so don't go too fast. Because with subtraction, easiest way to do this, even though you can still do horizontal and vertical, a lot of us have problems with subtracting integers. So what I like doing is distributing this subtraction out to make it addition. Now, what I mean by distributing is that I'm just going to change all the signs of these terms. Okay, so I keep that first polynomial the same. I have 4x squared plus 3x minus 4. Now, I'm going to distribute that. So this is a positive 2x cubed, so it becomes a negative 2x cubed. The next one becomes a negative x squared. Then the opposite of this would be positive x and a negative 2. So see how the second polynomial is now the opposite to what we see, because now all we got to do is add like terms. I'm going to use a different color this time for my shapes, just so you don't get confused with all the writing. So the highest degree I see here is, oh, I see I made a mistake. Did you guys see it? I put 2x squared here. It's supposed to be x cubed. Okay. So I'm going to start with my highest degree. My highest degree is x cubed. That's how I found out I made a mistake there. And I'm going to circle. And as I see here, it is the only term with an x cubed. So I don't have to do any more circles. Then my next one would be an x squared. So I'm going to put a square around my x squareds. Don't forget that sign in front. I'll put a line under my x to the first. And then let's do a diamond again for our constants. Like I'm running out of shapes, huh? Okay. Now I'm going to combine my shapes with the largest one first, which is that x cubed. We only have one term with x cubed, so right away, all I have to do is just put down the x cubed. And it is a negative 2, so I do not want to forget that negative sign. Then I go to my x squareds. I have 4 here and negative 1 here. 4 plus negative 1 is 3, positive 3x squared. As I can see now, I go to my x to the first. I have 3 here and 1 here, so that is 4, positive 4. And then x, don't forget the x. And then my constants, I have a negative 4 plus a negative 2, which is a negative 6. And there is my answer. What I would like you to do now is pause the video and do the first 2 questions on the worksheet you were handed in class. So that way we can test to see what you picked up from this lesson so far. So pause and then continue. All right, hopefully since this was our first lesson, that you did pause, you did do your first question on that worksheet, and that you got it checked by me, and we can move on. So our next idea that we're doing is multiplication. So there's a couple ways, again, how to multiply. Here we have a binomial, 2 terms, multiplied by a trinomial, which is 3 terms. So this one they have here as distribution, but it doesn't look so smooth to me. And then we have our box method. Sorry, guys, I'm pressing the wrong button. It's been a while since I've used it. All right, so with multiplication here, we can do it distributing like I just said, or box method. Distributing this way they're doing it is kind of confusing. I tend to do, I'll call it rainbows, that type of thing where I'm like, okay, the 4x multiplies to the 3x squared. That's where we get the 12x cubed. Don't forget, when you multiply, you add the exponents. Remember, combine like terms up before. We don't change the exponent, but when you multiply, you add those exponents together. So 4x times 3x squared is 12x cubed, because this is to the first, right? And then I would go 4x times negative 5x. Well, 4 times negative 5 is negative 20, and x times x is x squared, right? 1 plus 1 is 2. And then I would go 4x times 1, which is just 4x. Then I do that with the next term to each, okay? This gets a little messy, you see. If I had another term to multiply out, I have so many of these arches going to tell me what to do. So that's why organized-wise, I like the box method. Now, with example 3 here, okay, because let me just tell you what the box method, right? So it lines it up. I can line up -1 and, or -2, and 1 is -2. -2 and -5x is, this actually is incorrect. This should be a positive. Right? Yep. Positive, because a negative times a negative is a positive 10x, so on and so forth. Okay. Now, in example 3 is something we're going to run into a lot this year and next year in higher math. It's a binomial times a binomial. Some of you in the past may have done this by what we call FOIL. First, outer, inner, last. If that's how you remember how to do this one, go for it, continue. But I'm going to do the box and stay at one process. So I draw my box. Hopefully it's big enough. Okay, and I put my first binomial on top, which is 5x minus 7. Then on the side, I have 2x plus 9. All right, now what I'm going to do is multiply. I'm going to use a different color so we can see. So 2x times 5x. 2 times 5 is 10. And x times x is x squared. Remember, this is to the first. And if I add the exponents there, that's where I get the 2. Okay, let's do these two. 2x times -7. Well, 2 times -7 is -14. And then we're just left with x to the first there, or x, because there's nothing to add it to with that. 5x times 9. Well, 9 times 5 is 45. And then that x is just there. And then 9 times -7 is -64. Okay. So now, not 64. Wow, can I multiply, guys? 63. It is the end of the day. Forgive me, I'm tired. See, it's the end of the day for me, probably the beginning of the day for you. Okay, now I'm going to combine like terms, just like what I did with addition. So I find my terms that look like each other, and I see here with the box, it's that diagonal right there. Now, 99% of the time, this is going to work out nicely. So I'm left with 10x squared. Then I'm going to add my x's together, my x to the first. So 45x plus -14x is 31x, a positive 31x. And then we have our constant there, which we don't have any like terms like that. So right at the end, minus 63. And we just multiply two binomials. Okay, this is why I like the box method here, because again, it gets messy, right? So what I'm going to do, because I only have so much room, right? So I'm actually going to put my binomial on the vertical side here. And I'm going to put my trinomial across. So 6x squared minus 7x minus 5. Down, make my boxes. All right, multiplication. So we need to add the exponents, right? So let's do this first box here. 2x times 6x squared. 2 times 6 is 12. And x to the first times x squared. Look at the exponents, add them together, we get x to the third. Okay, next box. 2x times negative 7x. 2 times negative 7 is negative 14. X times x is x squared, right? 1 plus 1 is 2. 2x times negative 5 gives us negative 10x. And now let's go down to the bottom row here. 6x squared times 3. Well, 6 times 3 is 18x squared. 3 times negative 7x is negative 21x. And 3 times negative 5 is negative 15. Just take your time when it comes to those positives and negatives, because that's where our small mistakes can be. Okay, we filled out our box, but now we're going to combine like terms, right? So as you can see those diagonals like I pointed out before? Most of the time that's going to happen. So I'm going to add them together. So first of all, my largest term is 12x cubed. Now 18 plus negative 14 is a positive 4. Because I'm combining like terms, that variable and exponent stay the same. Then I have negative 21x and negative 10x. So that gives me negative 31x and then minus 15. It's nice too because it goes down. If I had any repeated exponents, I know I did something incorrect. Let's see if we can go one step further. Again, why I like the box method. And then I'm going to have you finish your worksheet and do 2 problems by yourself and show me what you did before you go on to your practice. So I'm going to have to make this bigger, right? Because it's trinomial times a trinomial. So 2x squared plus 4x minus 3 6x squared minus 3x minus 8. I didn't space that out nicely, did I? All right, a couple more boxes to fill in this time, right? All right, 2x squared times 6x squared. Well, 2 times 6 is 12. And x squared times x squared, remember, what do we do to those exponents? We add them. 2x squared times negative 3x. Well, 2 times negative 3 is negative 6. And x squared times x to the first. Add those exponents, we get to the third. Like how it goes down, right? 2x squared times negative 8 is negative 16, and we keep our x squared. 4x times 6x squared. Well, 6 times 4 is 24. And then this is x to the first times x squared. Well, 1 plus 2 is 3. 4x times negative 3x is negative 12x. Add those exponents, we get x squared. Now look how I organized this. See how I went over? I almost forgot that negative. So be careful on how you're writing things. 4x to the first times negative 8 is negative 32x. Okay. Negative 3 times 6x squared is negative 18x squared. Negative 3 times negative 3x is positive 9x, right? A negative times a negative is a positive. Negative 3 times negative 8 is a positive 24. Like I said, many of you will know how to do this, but you want to always practice because you mess up on your negatives and positives. And again, look at this diagonal. You're going to combine the x cubes. You're going to combine all of the x squareds. Combine all of the x to the first. Okay, so let's see what we get for our answer. So that first term there is 12x to the fourth. Then we get our x cubed, so 24 plus negative 6 is 18, positive 18x cubed. All right, so negative plus a negative plus negative is still a negative, right? Not multiplication stuff, guys, remember. So negative 18 plus negative 12 is negative 30. Negative 30 plus negative 16 is negative 46 x squared. Oh, look what I did here. What did I do right here? Oh, this is cubed. So guys, in my video, I'll pause, I'll make a lot of mistakes and stuff, but it's because these are common mistakes, especially when you go too fast. Lucky for me, I'm catching them. Hopefully you're catching them before I do, right? Just heck, what are you doing? You're incorrect. Okay, we are on our x's. So positive 9 and negative 32 is a negative 23x. And then we're left with this positive 24. I have one more thing before I want to move on to the 2 questions that I gave you in class. And I want you to check with me is this. I know one of the questions is going to have a monomial, which is one term, that we distribute. And this is where I like the distributing question. So I'm going to add something in right here. What if let's pick a number. Let's do 3x to the fourth. And let's multiply it by a binomial. Let's say 2x squared. And let's go minus 7x. Okay, what happens when we have something like this for multiplication? This is where distributing, you can still use the box method, but this is where I prefer distributing because I'm just taking that one term and then multiplying it by both of those terms in there. So let's do that now. 3x to the fourth times 2x squared. Well, 3 times 2 is 6. And x to the fourth times x squared. Remember, we add the exponents. So that's x to the sixth. Okay, and that's the first term. Now let's go here. 3x to the fourth times negative 7x. Well, 3 times negative 7 is negative 21. And x to the fourth times x to the first. Add those exponents, we get x to the fifth. And that is our answer. Okay, so what I want you to do with this is I want you to do the last 2 problems on your worksheet, double check with me, and then you can start your practice because you're ready to go.